Hello, today we're going to look at 7.3. So find that page in your packet. We're going to talk about triangles. There are three triangle names that you may be familiar with. An acute triangle where all three angles are the same. So there's the same symbol for each. A right triangle where we have the 190-degree angle. And then the obtuse where you have one big angle. Okay, but the main focus for us to get started is this triangle sum theorem. Okay, so the triangle sum theorem is saying that if I have a triangle, okay, any triangle, big or small, any shape, as long as it's a triangle, it's going to add up to 180 degrees. So A plus B plus C is 180 degrees. So let's put that into work. So looking at example 1, I have angle X, angle Y, and angle Z. If I add them all up, it equals 180. So X equals X. The measurement of angle Y is 35, and the measurement of angle Z is 35, equals 180. What I've made here is an equation, and we spent a lot of time this year practicing our equations, so I know that I need to clean up the left side of my equation, so it says X plus 70 equals 180. Now I solve my one-step equation. My inverse is to subtract 70 from both sides of my equation, x equaling 110 degrees. So that's our answer. This angle here at the top is 110 degrees. Alright, the triangle off to the right. Again, I have three angles that equal the 180 degrees. So X is the measurement of angle U plus the measurement of angle V right here is 20 plus the measurement of angle W, that obtuse angle at the top, is 122. All three of those angles equal 180. Again, I've made an equation. Clean up the left by combining my like terms. X plus 142 equals 180. And now I have that one-step equation again, where I need to subtract from both sides. Okay, so X equals, need to borrow here, and I get 38 degrees. And that does look like an acute angle, so I'm good. I could check it if I wanted to. I can check by adding 122 plus 38 plus 20, and I should get my 180. So there is a way that I can check my work. Sliding down a little bit here, I have some more vocab words to review. Equilateral triangle is when we have three congruent sides. So, equilateral, we note that with three sides with the same amount of tick marks. An isosceles triangle is when we have two congruent sides. So I have this one and that one are congruent. And then we have scalene. Scalene triangles are when there's no congruency going on. So I can put 1 and then 2 tick marks and then 3 tick marks on the longest side. So all three angles are different, so no congruency. Okay, so let's make a special highlight down here at the bottom for our triangle inequality theorem. So this is wanting to know, can you always make a triangle? So, can you make a triangle? question. Okay, so that's what we're asking ourselves when we see a problem that says something about inequality theorem. So tell whether a triangle can have sides with the given lengths. Explain. So let's see what that might mean. Okay, go ahead and pause the video so you can jot down our two examples so we can talk about this triangle inequality theorem. So first, I'm going to circle the longest side, okay, because 11 is longer than 4 and it is longer than 9. So that is my longest side. So for these three lengths to form a triangle, 9 plus 4 has to be greater than 11. So is that true? So, well, 9 plus 4 is in fact 13, so it is greater than 11, so that is a yes. It will form a triangle. Okay, so yes, will form a triangle. Okay. Over here, off to the right, we have a different situation. We have a 3 foot, a 6 foot, and a 10 foot. If I had those side lengths, can I form a triangle? So same idea. This is my longest side here with the 10. Okay, so longest side is 10. So if I take 6 plus 3, it has to be greater than 10 for this to form a triangle. So does it work? Well, 6 plus 3 is only 9. So no, it is not greater than 10. So no, triangle cannot be formed. We're going to do some demonstrations in class and show you why this doesn't work. But that is how you can show your workspace on it. But in class we'll show you some examples of three sides that do not form a triangle.